Imagine having a recipe at your fingertips and a picture of the delicious result, all created by AI. Get ready to transform your kitchen with the power of OpenAI and DALL-E. In this tutorial, I will show you how to build your very own recipe and dish image generator. Hello everyone. If that intro got your stomach rumbling, you are in the right place. I am Atfataya and I am fascinated by the way AI changed how we do, well, almost anything. Today we are channeling that fascination into the kitchen. In this tutorial, we are going to combine the recipe generating smart of OpenAI and the artistic power of DALL-E to create something truly special, a recipe and dish image generator. Think of it as your own AI cooking assistant. You tell it what ingredient you have, and it will build a delicious recipe complete with a picture of the finished dish to inspire you. Whether you are a seasoned chef looking for new ideas, someone who wants to improve their cooking skills, or just super curious about AI, this project has something for you. So, put on your virtual apron and let's embark on this exciting cooking journey with AI. In this part, as usual, we will start by installing the required libraries. So we'll say pip install OpenAI quiet and pip install python -env/q. Next, we are going to import OS to access the hard disk and import OpenAI as well. Next, we are going to create a function to load the OpenAI API key. I have already generated an OpenAI API key from OpenAI account and I save it in a .env file in my hard disk. So here we'll say define setup _ open AI, then we'll say from OpenAI import OpenAI from .env import load find, then we'll say here load.env find .env and then override is equal to true. Now we will create the client. We'll say client is equal to OpenAI for API _ key is equal os.environ.get OpenAI _ API _ key. After that, we are going to print a message to the user when it is successful. So we'll say API key loaded os.get environ.get here's a mistake, not get .environ.get OpenAI _ API _ key, and the condition is not none. Finally, we are going to return the client. Let's run the code. And the final step in this part is to create our client. So we'll say client is equal to setup OpenAI, the function that we just created. If it is successful, we should see a message API key loaded true, and we get the message. Now in this part, we are going to create the function to generate the recipe. This function will take a list of ingredients entered by the user, and then it will return the recipe, and we want to format our response as recipe title, list of ingredients with portion and size, and also the instructions. So let's start working on it. So we'll say here define generate _ recipe. It will take list _ of ingredients. Okay. First, we have to define the system prompt. So we'll say system prompt is equal multi-line string, and so we'll say you are a top class chef. All right. Next, we will define the user prompt. So we'll say user underscore prompt is equal to f multi-line string as well. So we'll say create a detailed recipe based on only the following ingredients. This function receives a list of ingredients as a Python list. So we want a way to combine all the elements of that list into a single string. And since we are going to specify comma as the joining character, it will insert that between each ingredient. So what we have to do is the following. So we'll say dot join list underscore ingredients. Okay. Next we'll say please format the recipe as follows. Recipe title and then recipe ingredients with size and portion, and then list of instructions for this recipe. After that, now we will define our client. So we'll say here response is equal to client.chat.completions.create. For the model, I'm using GPT-3.5, but feel free to use any other model, Turbo. And for messages, we have role, system, and content system prompt. And for the user, we have role, content, user prompt. Okay. Now for the token, we are going to use max underscore tokens equal to 512. This variable you have to experiment with while building this function. And for the temperature, we want it to be creative, so I'm going to use 0.9. And finally, we are going to return the response. So we'll say return response dot choices index 0 dot message dot content. Let's run the code, make sure everything is working. Now let's test this function. So we'll say here text underscore response is equal to generate recipe, and I'm going to pass the list of ingredients here. So we'll say eggs, bacon, ham, turkey, and bread. Okay. And let us now print the response, which is going to be the recipe. And let's run the code. And we get the response. This is the recipe title, ultimate breakfast sandwich. And this is the ingredients, and this is the list of instructions. All right. So for the first part, we are finished now. Next, we are going to work on the image generator. DALL-E is a trained neural network that, according to OpenAI documentation, is a version of GPT-3 that uses a dataset of text images pair. Like GPT-3, DALL-E is a transformer language model. Transformer language models are a new type of neural network that can be scaled up and trained on a huge dataset. These transformers are considered revolutionary in the natural language processing and are being used by many AI models. Now back to DALL-E. From text description, DALL-E will generate a large set of images. These images are ranked by another OpenAI neural network called CLIP. A CLIP will determine which of the images match best. CLIP has two components, text encoder, and image encoder, and was trained on 400 million pairs of images and text caption scraped from the internet. In this part, we are going to create the dish image generator function. This function will receive a recipe title, and based on the recipe title, it will generate an image for us. But first, how to get the recipe title? If you remember here in this part, in the text response, we receive the recipe title, recipe ingredients, and the list of instructions. After that, we have to pass this recipe title to the image generator function to generate an image for us. So let us start first by getting the recipe title. Okay, it's just a small function. So we'll say here define get underscore recipe underscore title. It will receive the text, which is a text response, because we are going to extract the recipe title from the text response. All right. Next, we are going to say lines is equal to text dot split lines, and then we are going to return lines of index 0 dot split colon and then 1. All right. Okay, so what we are doing here is we are getting everything after the colon, okay, at index 0. Let's run the code. It's working fine. For testing purposes, let's say we have recipe underscore title is equal to get underscore recipe, and we are going to pass the text underscore response. Let's run the code, and we have to print it. I forgot to type here print recipe title, and we get the title, the ultimate breakfast sandwich. All right. Now we have to pass this recipe title to the function to generate an image for us. Okay, so let's start writing the code now for this function. So we'll say here define generate underscore image recipe underscore title. Now we have to define our prompt. So we'll say prompt is equal to a photorealistic image of recipe title, close up. We want a close up shot with emphasis on texture, colors, and on ceramic plate. Note that a new feature in latest DALL-E 3 API is prompt writing, where it uses GPT-4 to optimize all our prompts before they are passed to DALL-E. And in OpenAI research, it has been seen that using very detailed prompt gives significantly better results. Okay, next we will define now our response. So we'll say response is equal to client dot images dot generate. For model, I'm going to use DALL-E-3, and for prompt we are going to use the prompt that we just created. Now for style, by default the value is vivid, but it could be natural. Vivid causes the model to lean toward generating hyperreal and dramatic images. Natural causes the model to produce more natural, less real looking images. The next argument is size. I'm going to use 1024 by 1024. When using DALL-E, images can have sizes of, I'm gonna type it here, 1024 by 1024 or 1024 by 1792 or 1792 by 1024 pixels. The next value is quality. I'm going to use standard. By default, the images are generated at standard quality. But when using DALL-E 3, we can set the quality to HD for enhanced detail. Standard quality images are the fastest to generate, and I recommend for you to look at the image model's pricing to avoid any surprises. The next argument is N. it's equal to 1, which means the number of images to generate. Note that at this moment you can generate one image with DALL-E 3 or up to 10 images using DALL-E 2. To request more images using DALL-E 3, we should make parallel requests. Finally, we are going to say here return response.data at index 0. Data is the list of images, and we want the image at index 0, and we want the URL of it. Let's run the code and make sure everything is working fine. And it's working fine. Now let's test our function. So we'll say image underscore response is equal to generate image, and we are going to pass the recipe title that we get before. Okay, and we are going now to print the image underscore response. Let's run the code, and we get the URL of the image. If we click on this URL now, and this is the image of our recipe, which is called the ultimate breakfast sandwich. Okay, note that the more detailed the description in the prompt, the more likely we are going to get the wanted result. Now let's save the image to a file on the disk. We can do that by switching the response format from URL to base64 encoded image data. Or we can leave the URL response format and get the image using the request library. In this example, I will use request library because we already have the image URL. So what we have to do is the following: import requests and import shootel. This library is used to copy files. After that, we are going to make an HTTP request using the request library. It's like getting an image on an HTTP response object. So we'll say here image underscore resource is equal to requests, the request library dot get image response, and stream is equal to true. Stream equal true is necessary to get the raw content of the response. Let's print the image resource and check the result. Image underscore resource. We get a response and status 200. This is an HTTP response object which has a status code 200, which means success, and the other code that started with 4 means error. Okay. Next, here we'll say if image underscore resource dot status code is equal to 200. We are going to have here an image underscore name equal DALL-E -3 recipe.png. Okay, and then we'll say with open, we are going to open our image underscore name with binary as F. So we are opening the image name in a binary and write mode with open. Okay, next we are going to use the shootel to copy the raw content of the HTTP response to the file on the disk. So we'll say shootel.copy file object image underscore resource dot raw comma F. Else, if it's not 200, we are going to say print error accessing the image. Okay, let's run the code again. Response is 200. So using this, we saved the image to a local file on the disk. Now, if we want to display the image on the Jupyter notebook, we can do the following. We have to install pip install pillow -q. Quiet. Let's run the code. Next, we will say from Python image library import image. and then we'll say image.open image underscore name. Okay, let me just scroll and run the code. And this is the image of our dish. Okay, so to recap, we created here a function to generate a recipe for us using our list of ingredients. This function returns the recipe as the recipe title, ingredient, and list of instructions. Then we wanted to create a function to generate an image, but this function needs a recipe title. So we define here a function to get the title, and then we passed it to this generate image function, and this one returned to us a URL of the image. To save this image locally to a file, we use request and shuttle. Request to get the response object, and shuttle to copy the file locally. And to display the image on the Jupyter notebook, we use the Python image library. Okay? And that's how you create a recipe and dish image generator. There you have it, your own AI-powered kitchen companion, ready to spark your next kitchen adventure. I'm very excited to see what delicious creation you will cook using this tool. Share your recipes and images masterpieces in the comment. If you like this tutorial, hit the like button, subscribe for more AI adventure, and don't forget to share this tutorial with your friend. Thanks for watching and happy cooking.